Let's make some predictions. What do we expect this one to look like as compared to this one? What will be different? It'll be reflected or upside down. And that was kind of a big debate in the activity Friday where you guys were chatting. If it's upside down, then the arrows go down. So instead of the arrows going up, it's going to reflect and the arrows will go down, pointing down. How else will it be different? It's this negative sign that flips it over. What will the -5 in the end do? Go ahead.
The chart. Where's the graph down? Like,
So it's going to drop it down 5 units. So it's kind of your decision. You could plug in to your equation and make a whole new table, or you can just try to redraw it. How confident are you guys that you could just right now draw this upside down? Let's see on a scale of 1 to 5. 5 is you're perfectly confident. Just put your hand up. I could definitely draw this upside down. Okay. Yep. So here I go. I'm going to draw it upside down. I'm going to do it quickly without a table. Just upside down is the same vertex. Are you guys going to look? Abby, you going to look? Yeah. So instead of this point being here, if it's flipped across X, it'll be here. Whoa. You're good with that, Nathan? Yes. You're good with flipping? Yeah. I didn't see your 5. So Vladimir, I put this down here because I'm reflecting across the x-axis. And then I'll take this one, which was 408, and I'll reflect it down. Yeah, it's a reflection across X. So here's the flip. Okay, so this blue one is y equals -x squared. I mean, if you don't want to make a whole table, just redraw it. Just do the reflection. And now we got to drop it down 5. So now I'll take every point and count down 5. So from 5 we'll be at 6, 7, 8, 9. And that's -x squared minus 5. So that's how you graph using transformation. That's less of a table necessary. You can still do that. If that's difficult, you can still just plug in points. Plug in -2, -1, 0, 1, 2, and get points out. And that'll also create the green parabola. So who would rather make the table and plug in points instead of doing it like I just did it here? Who would rather do it like I just did it here? All right, so it's even. It's even. I got as much people saying this as that. So I'll go ahead and do this then. If you can master the first way, it's going to be quicker. And you'll also answer some higher level questions more easily, but because here, now I'm opening myself up to math errors. So you got to square it, multiply it by -1, and subtract 5, and that works out -9. So if you're not confident in that, you should really learn the transformation method, where we flipped it over and counted down 5. All right, so I've done both. You need to do one or the other. It's your bell word. Are you going to do counting? Are you going to table also?
Fucking throughout. About PPA range from 1.8 to 2.3. From 1.8 down to 2.3. Oh, the semester rates. Like,
Can I see your system?
God damn, what the fuck is it? Like, they're like 3 pages.
Drop it down 5.
That's quarter two. That's why. They're all these. I'll take it to 2.3. God forbid, I will be on the first one. I can. Miss Fabry, the same class as I am. So building 2. No, building 3, my fault.
It's okay. Decided he was just gonna track on just about it. So I've let him in a few times because we had a whole talk about it. Because he can't make it on the list either. So it's funny, the people coming from the furthest away, you have less time and you can get on the list. The people who get here quick get on the list first, and they probably could go to the bathroom before they even. So you just need to.
Yeah, you gotta run. I'll be like,
Talk to me about it. And I can tell, but if I see you, Kate almost got him in trouble one day because there were some people just standing outside. I see you, sorry, I'm gonna send you this already. But if you just go.
because I come from the
Straight to the
center.
Oh, I
Right.
think that's 400 too. I'm not that smart. It's like a study hall basically. So it's pretty good. Oh, I know. There's all these courses. Yeah.
I got something to tell you I haven't mentioned before. So everything so far we've done, I've mentioned before. I got something to tell you about before. Remember, A is the number in front, B is the number in the middle, C is the number at the end. The presence of B will shift the graph left, right. And it's not real obvious about how much left, right it'll shift. So, all day Friday, all day Thursday, and now this one, x squared minus 5. Notice there's no x in the middle. Every one of the graphs we've done has been right here on the y-axis. Today's graphs are going to be more complicated. There's going to be a middle number in here. And it's going to require significantly more steps to create. So I have a handout to help you keep those steps organized in your mind. Maybe use it on our next quiz. You want to close the quiz?
Oh, I was just.
No. I mean, no. No, fam, no, I don't say that. Say no.
Oh, yeah, I know. Hold on. Well,
Not right.
yeah. What is it? You smart.
Are you guys doing it in Desmos? Yeah, that's awesome. Do it.
Okay. I know.
Okay, I can tell.
And
Yeah. So, the axis of symmetry is more complicated with the presence of A, B, and C. So there is a formula for it. Check it out. It's negative B over 2 times A. I find that students will struggle with the negative sign. So this is how the formula is presented, but I want you to rewrite it as negative B up top over 2 times A. Okay, so a negative sign right in the middle of a fraction bar, students think, well, is the top negative or is the bottom negative, or are they both negative? So you guys go ahead and rewrite it with the negative up top and the bottom as 2 times A. And then this is also helpful. C will be the y-intercept. So in this Bellward question, A is negative 1, B was 0, was not present, and C is negative 5. So yeah, there's the y-intercept at negative 5. All right, so these directions are, did you have enough time? Yeah. These directions are so long. It says that we need to find the y-intercept. We need to do the formula for the axis of symmetry. We're asked to identify the vertex. We have to say whether the vertex is a high or a low value. We're asked to do domain and range. Then we're asked to do a table and make a graph. So it's like totally show knowledge about this equation in every aspect. It's not just a graph. It's like graph and talk about all the details. So, all right, first thing you want to do is identify A, B, and C. A is 1, B is 2, C is 3. See the A, B, C? Now, I don't see the 1. The 1's invisible. But I do see the B and the C. Then we're going to do the equation for the axis of symmetry. So plug in B and plug in A. So there's a negative sign, and then I put the 2, and then 2 times 1. And then I'm just going to simplify that formula. Negative 2 divided by 2 is negative 1. It says that we should do a dashed line for the axis of symmetry. To shorthand it, this is AOS, axis of symmetry. And we're going to put that as a dashed line. So find negative 1, the x-axis. It's the axis of symmetry. You know that the center where you could fold it and it's symmetrical on both sides. Now, all of our parabolas have been centered around the y-axis. Just today on this handout in this section, we're going to be seeing that it's not centered just directly in the middle anymore. It's being shifted all around. So the vertex, the center point, is somewhere on this dashed line. In order to find where it is, we're going to take the negative 1, yep, and we're going to plug it into both x's, and that'll tell us the y value of the vertex. So we're taking this answer here, and we're going to plug that answer into the equation. So you're plugging it into number 1. So it's negative 1 squared plus 2 times negative 1 plus 3. So then we have this PEMDAS challenge. I'm going to try to pause and let you guys take a good crack at it, see what number you get for y. And that'll be our center point.
Red. Well, I think I'm going crazy. I think I'm going crazy, bro. You saying my name.
It might be off. This one here would be, this would be a -2, James.
No.
Are you doing it? Are you gonna?
Are you on?
You can also graph this in Desmos and just tell me what the vertex is.
What?
1 minus 2 plus 3. So that's -1 plus 3, and that is 2. So congrats to everybody who got that right. Your negatives and your PEMDAS are good. So this is the vertex. It's the center. Right up there. That's an ordered pair. X, Y. -1, comma 2. So now we need points to the left and to the right because that's the center. So if you can just get 2 more points on the left side and 2 more points on the right side, you'll be done. That's your parabola. So for the table, the point you've already found, you can put in the middle. So we already know 1 point. We found it as the vertex. So now we have to go, wait. To the left of the vertex would be -2, -3, and to the right would be 0 and 1. The vertex has to be the center, the middle. Sometimes students will say, where do I start my table? And I say, it doesn't matter where you start it. What's important is what's in the center. This thing should be going around the vertex. Yeah, it needs to be in the middle. Put them in the middle. Because they're in the middle of the parabola. So overwhelmed. Anything? Are we done with this one yet? Alright, I do already know what the 0 is going to be. That's the y-intercept. So 3 is the y-intercept. So I can go 0, 3. So I want to shortcut this, Nathan. Everything is symmetrical, right? First, do you buy into this 3? Do you know where I got the 3 from? Where? From the problem. Let's go ahead and plot it. Yeah. Now let's shortcut the table. Let's reflect it over. And that gives us another one. Because that's a line of reflection, right? Shortcut. So if you have a y-intercept, shortcut it. Shortcut the table, reflect it over. So now I know -2, 3 is also a point. So it should be the same up top as below, as long as there's no fractions involved. Alright, we need one more. Should we try plugging in 1? Or do you want to plug in -3? 1 seems easier. Let's plug 1 into the equation and see what we get out. So this whole table is based on the problem. So one good thing to understand already at this point is that we're going to put this x in here and here and try to get the right y value out for the table. So, yeah, that's a move towards comprehension, is knowing that we're putting the x in here and here and trying to find y. So that would be 1 squared plus 2 times 1 plus 3. I'm going to pause again. Let's see if we can get the right answer. Rumor has it might be 6. How are you doing it? It does look scientific? And are you looking at the graph or are you using the calculator? That's good stuff. You're going to try it, Ari?
No, I'm not.
1 plus 2 plus 3?
We add that in our calculator.
You could. Okay.
Oh wait, which one are we doing?
So I wanted to plug in 1. And so that's 1 squared plus 2 times 1 plus 3.
Oh, okay. First one.
Did you get it? What did you get? Oh, another person was 6. 1 plus 2 plus 3. 3 plus 3, 6. So our last ordered pair is 6. Nathan, if I want to shortcut it, I'm not going to do this one. I'm just going to reflect it. So it'll be the same on the top and bottom. So if you think that like the positives are easier, then do these ones and just copy them up top. There should be symmetry in the table. Actually, no, because of the way a parabola is, the y values are the same on the left and right. They're both positive. And that's because when you square something, it goes positive. So it's at positive 6 and positive 6. And so it goes down, turns, and comes up. And that's why it's a parabola, because of the symmetry. All right, pretty good parabola. So this one is way more advanced than the ones we did last week because it shifted just left one unit. Real quick, I'm going to do domain and range. So the domain is all real numbers. That sounds familiar. And the range is y is greater than or equal to, anybody know it?
2. 2. Negative 3.
It's 2.
Why did I pick 2? It's the same number that's in the vertex, okay, guys?
Yes.
So whatever number's in the vertex, that's in the range because it shifts down to 2 and shifts back up. It's called a turning point. All right, send your paper over. We're going to do all those steps again on number 2.
Alright, but I fixed the ring before you. I was close. Are you gonna get X number with the right one? Basically.
What? ABC.
Okay. Get out. Oh my god. Hey, Brad, where's my monkey? Guys, not saying Brian.
All right, here we go. You know what I like to do? Right above it, I like to write ax squared plus bx plus c. You know what else I do? I give a whole point for just identifying what a, b, and c are. That's general.
Yes.
So first I want to say a is negative 3, b is negative 12, and c is negative 8. Well, these numbers are way bigger than the one we just did. All right, number 2 is to find the axis of symmetry, which means we have to do negative b over 2 times a. You have to do a formula. Negative b over 2 times a. Axis of symmetry. So I like to shorthand it with that acronym. All right, so this is kind of weird. B is already negative. So when I plug B in, it's going to be a negative, negative 12. Yeah, look at that. James, that's the situation where things go positive. When you see that negative sign for the negative. The two negatives make a positive. This is advanced. Algebra 2, just like this. like all over again. All over again. It's an Algebra 1 standard. It's on the ESC. It's a part of the curriculum. But when we add to it in Algebra 2, we teach it all over again. Give you a second chance. Try to figure it out.
If we fail our bro, and then you're the class.
The test?
If we fail the test,
Yes, the
we
class.
pass. No, you're the whole point of the test.
Well, you need 4 high school credits. So you'll need a math credit. Math credit.
Like I got a 30 on that.
But it's almost me to like give that's all.
Are we supposed to be doing something?
That's everything. How am I not LeBron? I'll literally do LeBron edit right now.
Bro, every day.
Anybody got a number? Anybody? Okay, I'm really glad you guys all tried. Good job. This is 12 over -6, which is -2. And what's
Again?
There's actually been a change of policy over here, but I'm not sure, but- So here's -2. What's step B? So now we're gonna plug in x equals -2 to find vertex. So that would be y equals -3 times -2 squared minus 12 times -2 minus 8. Last week, there was a bell work question that was just evaluate. It was just plug in. So if your question was just plug in -2, you'd feel fine. I can do that. So just don't feel like, oh, it's so many steps all together, it's overwhelming. But you know what? Just plug the number in to do the math. Remember, exponents first. Exponents first.
What? You know what? What am I doing? Bro, yes you do.
Our vertex will be -2, 4. There's the center. Yes? Did you get a 4 out, you?
I did.
Good job.
There's my right arm.
4.
Oh.
Is it easier with the calculator? Not calculator. All right, moving on. Gosh, I'm kind of out of room. Last thing we have to do is a whole little table.
Look at that good girl.
Y'all be quiet. If you're talking about something other than this, you're less likely to A, understand it, B, recall it. How are we going to make our table? Genevieve, what's in the center of the table?
Oh, -3. -1. 4.
She got it. -2, 4. The vertex goes in the center.
Oh yeah.
And then you need some points to the left, and you need some points to the right.
44. No, it's 3. 1 and 3. Shouldn't take that.
Can you predict what's going to go with the 0? 0 what? -8. Did you say -8? You got it. How did you know that was -8? The C value, you guys, the y-intercept is given. You always know the 0. It's the C value. So that's a good shortcut. I can reflect that to the top.
Oh, me?
-8.
From when I'm looking the thing?
Wait, how is it negative 8?
The -8 next to the 0.
Oh.
This number at the end always pairs with 0. Well, it's reflected. So it matches inward. So since the equation gave us this one, we can cheat code it and reflect it up to this one. It's a shortcut. I don't know. I don't know until I do the math. That's a good prediction. So I'm at 0, -8, and I'm reflecting it over. We only have to do one. We can do this one or this one. Whatever we get, we can reflect over if we're confident in it. Which one should we do? Should we do -3 or -1?
Negative.
-1 seems easier. Let's do -1. So here we go. We got to plug it in. -3 times -1 squared minus 12 times -1 minus 8. Everything's hinging on this one. You ready, Nolan? You do it, okay? Use your decimal sign. This is on your exam. Use the decimal sign calculator. Do it. Your state exams calculator is designed from Desmos. Well, they're not going to allow you to access the graphing feature on every question. But for the most part, it's mostly that calculator. Make sure I'm watching everyone's internet. Yeah, but it's just it's a lot to go back and to look through when I'm also passing out papers and things. I don't think that's right. Alright, so I'm going to squish this in. This is -3, +1. This is going to become plus 12 minus 8. -3 plus 12 minus 8. 9 minus 8, 1. -1, 1.
And then that's a 1.
I really want to talk about this parabola. There's something different about it. 1? Did you get 1?
Or which one? Number 2 or number 1?
1.
We have 6 minutes.
How do you read? It actually came out positive.
Positive 1?
Positive 1.
I use it.
That's funny.
Oh, yeah.
Funny.
Alright,
So I want to talk about this. The arrows go down. It's reflected because A is negative. It's also skinny. It's skinnier than the bellwork ones. It's skinnier than the ones on the front because 3 is a vertical stretch, so it's skinny by a factor of 3. We did a bunch of 3s on your graph paper I gave you, so it's reflected and skinny. Let's do domain and range. What's the domain? All real numbers. No, here's the tricky one. What's the range?
Range is
Y is less than 4.
4 is the highest amount, and it's going lower. That 4 is actually called a maximum because it's the highest value. The max is 4, so we say the range is everything less than 4. So your assignment today is posted on Big Ideas, but it's open till Friday.
Yeah.
It's open till Friday. If your last name goes from R to Z, please take Chrome up to the car. Up.